Salam Doctor, I am Siah Yih Hoong and today I'm going to do a video explanations on my lab tests and I'm from group 1. So let us get into our first questions. So the first questions require us to find the output signal, which is Yn. And since the input signal Xn and the impulse response Hn is given, therefore we just have to multiply the Xn and the impulse response together. And because of it is multiplying each other's means that impulse signals is multiplying with impulse response. By then, it will undergo a process known as convolutions. So how do we need to perform a convolutions with these equations? So let me explain first. So as you can see that we're having these two equations, right? Okay. So these equations is the input signal and this is the impulse response. So we can see that we have many weird stuff right here. These things and n-1 and n-5. And normally we just have straightforward equations, but then we need to perform some steps, okay, to get the correct input for our MATLAB. So let us take a look. So we have Xn is equal to n minus 6 n minus 1 plus n minus 5. So actually we can set n equal to 0 from the square bracket right here. By then we can find the locations. So n equal to 0 will remain at 0. And then we have n minus 1 equal to 0 and n will be equal to 1. And then we will have n minus 5 equal to 0. We will have n equal to 5. So we already have the n locations for the input signal. So what is the magnitude? So we can look back at the equations. So for this, it is something similar to 1 multiplied by n, right? So it will having a magnitude of 1. And then we look for n equal to 1. So by then, it is minus 6 multiplied by these things, n minus 1, right? So, oh, sorry, this is 0. Okay, so x1 will be minus 6. And for this x5, we look back, we will have positive 1 equal to 1. So the things happening right here is something similar to a tables. So we can make an example like this. Our n starting from 0, 1, 2, 3, 4, and n by 5. Why? Because our equations have minimum n value of 0. This is the minimum value, and maximum n value of 5. So this is why we end it at 5. So this is the magnitude. So when our n equals to 0, we will have the magnitude of 1 right here. So when our n is equal to 1, we will have a magnitude of negative 6. When our n is equal to 5, we will have 1 as magnitude. So what is the magnitude of 2 and 3 and 4? So, okay, by looking at the expressions, we don't find any things like n minus 2 so that we can find n equal to 2, right? This is because of their magnitude is 0. Why? Because 0 multiply anything it will become 0, right? Even 0 multiplied by n minus 3 still become a 0. 0 multiplied by n multiplied by 4 will become 0. This is why the following magnitude for 2, 3, 4, n locations will become 0. So what can we write for input inside the MATLAB? So let me erase all this first. Erase all this, a bit laggy. Okay, that's enough for us. So we will write something like this. Sorry. Okay, we will write something like this. X equal to 1 minus 6, 0, 0, 0, 1. Why? Because this is n equal to 0, this is n equal to 1, this is n equal to 2, this is n equal to 3, this is n equal to 4, and this is n equal to 5. Okay, so this explains why when inside MATLAB, for the x part in question 1, we will have equation like this, or the code segment like this. So the things happens the same for the h, sorry, for the h. Okay, so for the h, we have n equal to 0, n minus 3 is equal to 0, n equal to 3, and the magnitude x 0, sorry, h 0 is equal to 1, and this h3 is equal to -1, so that something similar happen again. This is n, this is hn, so we can say that it starts from 1 and end with 3, and the magnitude is 1, -1, 0, 0. Therefore, we will write something like this inside the MATLAB. Why? Because this is n equal to 0, this is n equal to 1, this is n equal to 2, this is n equal to 3. Okay. So this is my explanations for this segment, this code segment. And then how I show my output. So actually I separate it into two figures. For the first figure, I'm using subplot, which means that I will have two graphs inside one figure. Why? Because of I'm having the row 1, column 2, and I'm the first, I will have one row, 2 columns, and then this is the location of my graph, the first locations, and this is the second location. And then I set the n, like the x-axis, how many n I will have, and then I use them plot, and then I give my title. For x1, I give xn and label for the y-axis and x-axis. This happened the same for my y. Okay, where's my y? For h, sorry, h. The h is our impulse response and x is our input signal. So how I get y means the output signal. I will just have to perform a function known as conv bracket to h, x and h. Why? Because this will help us to perform a convolutions, and then we plot it by stem, and then we label it. Hide this. Maybe I can hide it like this. Okay. So let us run. Okay. So as doctor can see that this is my input signal, this is my impulse response, and this is the output from the convolutions and is the output signal. Okay, let us perform to the next questions. So the next questions require us to perform a partial fraction with it, because we need to show the partial fractions expansions, and then we convert the S domain into time domain. So, okay. What is a partial fraction? So, let me give an examples. Okay. Let's say that we're having 2s plus 2, and then we will have s squared. Sorry. Minus s plus 2. Okay. So, it would be something similar like 2s plus 2 s minus 1 s plus 1, right? Minus 1. Sorry, this will be 2. So s minus 1, we multiply it, we will have negative 1s, and then plus 2s, we will have positive s, and negative 1 will multiply by 2, it will become negative 2. So s multiplied by s, it will become s squared. So if we want to perform a partial fractions, we will have to convert or simplify it into these factors first, and then we will do something similar like this. S minus 1, s plus 2 become a s minus 1 and plus b s plus 2. So the code for R, B, K equal to residue AB is that we are getting the values of A, B, and the value right here, value right here. Okay. So the R will be the value A and the value B, and the P will be the value of s minus 1 equal to 0. It will become s equal to 1, and s plus 2 equal to 0. It will become s equal to negative 2. So, and k will be the gain. What? So, we have, how to say, what is the AB? So the AB right here is actually the coefficients from this numerator and the denominator. And okay, I'm here to explain how we get the A and B. Okay, we wait for a while first for the Azan. Okay, so how we get the A and B? Doctor can see that in my MATLAB coding, I'm getting A equal to 1, 5, and my B equal to 1, 7, 8, 0. So this is because when we look at the numerator, the largest power inside the numerator is s power 0. S power 1, followed by s power 0 right here. So the value 1 right here is get from the s power 1. Okay, so we can see that the coefficient of the largest numerator, largest power in the numerator is 1 and followed by 5. So for the denominator, I'm having 1780. So this is because of the largest power inside the denominator have coefficient 1. And then the second largest having coefficient 7. The third largest coefficient having the third largest power having coefficient of 8. Okay, so how come the 0 right here will be appear? This is because of I'm having s power 3, right? I will have s power 2, I will have s power 1, and following by s power 0. So because of the magnitude is 0, and 0 multiplied by anything is equal to 0, and this is why we're having 0 right here. So this is s power 1, this is s power 0, this is s power 3, s power 2, s power 1, s power 0. So we have to get the A and B in order to perform Laplace transforms or to get our desired output. So let us take a look at our MATLAB coding. Okay. For question 2. So the same as right here, telling us that I'm using S domain for the following coding. So the A, I explained just now. B also, I have explained just now. And the RPK residue is to get the coefficients from the partial fractions. And the XS, we have to convert this AB to become something like this in order to perform the inverse Laplace. Okay, so to perform inverse Laplace, we also need to type out our equations. So since we have s plus 5 divided by s power 3 plus 7 multiplied by s power 2 plus 8 multiplied by s, so we just type it inside here and then we perform inverse Laplace. So this inverse Laplace right here will allow us to convert the S domain into time domain. And then we output our result in a much more modern way instead of something like this. So let us run our result, our code. Oh my God. Okay, where is it? Okay. So these will be the coefficients of our partial fractions, and it can be seen as the poles and 0. Okay. And this is the S domain. And this is the output of the function TF bracket something. And this is the inverse Laplace. Sorry, and this is the inverse Laplace things. Okay. Oh my God. Okay. So this is my answer for my question 2. Okay. And let us take a look for question 3. So what we need to do for question 3 is we have to obtain poles and 0 for the continuous signal in the S-plane and provide the answers in MATLAB commands. So we're having these expressions. We're having a sine expressions with 10 plus 2t plus 5 sine 4t. So what we need to do inside the MATLAB. So as doctor can see, end. So this pretty function, like pretty bracket something, allow us to view our expressions in a way like this. It will have a beautiful fraction right here instead of long code right here. So still the same, we're going to get the largest power, the coefficient of the largest power first. This is s power 0. This is z power 0. This is z power -1. And this is z power 0. This is z power -1. This is it and store it vector form. We have to declare the functions in this form instead of in this form. Okay, so after that, we get the partial fractions. And then by looking at the partial fractions, we will find the poles and zero. Why? Because s plus 0 over, sorry, can be 0, s plus 1 over something a, this will be 0, and this will be poles. Okay, so after that, I inverse the Z transform to convert it into n domain, and after that, I show my output with the pretty bracket something function, and then I plot it into Z plane, and then I'm giving a title of Z plane and open the. This is my answer. Okay, so we have to determine the stabilities. I can say that it is unstable because the poles are outside of this unit circle. Okay, so this is my explanation, and thanks for your patience to listening my presentation. Okay, thank you.